All right, free response problem 6 from the 2024 AP Calculus AB exam. We have this graph. The functions f and g are defined by f of x equal to x squared plus 2 and g of x is equal to x squared minus 2x as shown in the graph. Part A. Let R be the region bounded by the graphs of f and g from 0 to 2, from x equals 0 to x equals 2 as shown in the graph. Write, but do not evaluate an integral expression that gives the area of region R. Okay, this is not going to be an issue because we have the graph of f right here. This one's on top, the g1's below. Talking about this region here. So we just take the top function minus the bottom one, and we're going to have that running from 0 to 2. Yeah, 0 to 2. And f of x, which is x, I'm assume they want you to use the polynomial, x squared plus 2 minus x squared minus 2x dx. And maybe simplify it a little bit, but you don't have to actually evaluate it. The x squares cancel, and you get 2 minus or plus 2x. But as far as I remember from like past years' exams, if you leave it like this, or even I've even seen where you leave it as f of x minus g of x without the polynomial, they still give you credit. So I just better to be safe than sorry. Okay, so then let S be the part B, let S be the region bounded by the graph of G and the x-axis from x equals 2 to x equals 5 as shown in the graph. Region S is the base of a solid. For this solid, at each x, the cross section perpendicular to the x-axis is a rectangle with height equal to half of its base in region S. Find the volume of the solid. Show the work that leads to your answer. Okay, so you're gonna get some like funky shape like popping out of here. I used to be good at this. I'm gonna see if I still am, but please don't attack me if I don't draw a good picture. So this is gonna be this is the y. This is the x, and this will be the z, the third dimension where the figure will pop out. And then what we got going on here for the s, something like this. This will be your s, right? Okay, so then it's gonna be popping out where so the cross sections are going to be perpendicular to the x-axis like this. And it says the height is half its base. So this would be popping out maybe that much. This one maybe like that. Okay, it's okay for, a little sketch. You don't actually draw it. I just like drawing it. Yeah, I just like doing that. But in case, and the visual usually helps in case you're trying to struggle with these topics. But anyways, so you basically have cross sections that are rectangles, and you're going to integrate. The volume of this will be the integral from 2 to 5. The rectangles, remember, are the area of a rectangle is just base times height. Now, the bases are the g of x, because remember, this is a base. So let me draw like so you can see that. Like the base is, let's say you have a rectangle oriented like this. This would be the g of x. And the heights, this part, it's supposed to be, I did it the other way around, but whatever. This is gonna be half of g of x. Because it says the heights are half of the base. So then the area is g of x times g of x divided by 2 or g of x squared divided by 2, that sort of thing. So we're just going to integrate that essentially. We have 1/2 times x squared minus 2 times an x squared minus 2x dx, this whole thing. Do we have to, oh, we have to calculate it. Fun. Okay, so let's do this. Volume is then going to be the integral from 2 to 5, 1/2 times x to the 4th minus 2x cubed minus 2x cubed, so minus 4x cubed plus 4x squared dx. You can distribute this 2, so we get 1/2, and then that over 2. So that'll just become a 2x, 2x. And then integrating this using the reverse or backwards power rule, I like to say, call it. We're gonna have x to the 5th over, did I screw that one up? 1/2 times 1/2, the area is 1/2 of the base times the height. No, I didn't. So then, yeah, I think we're all good. Yeah, we're good. So this is over. So, okay, so to the 5. Okay, so then, sorry about that. Brain stumped. It's past my bedtime. Okay, so then 5 times the 2, 10. You get this over 10 minus 2x to the 4th over 4. And then plus 2x to the 3 over 3. From 2 to 5, you can, well, you don't technically have, you actually don't have to simplify this algebraically because, I mean, you don't get a calculator for this. So it could be risky, especially if you're running slow on time, but here I go. So I'm just plugging in what you would have to do. You plug this in, the 5s, then just the plus the 2 plus 5 cubed over 3, this whole thing minus now we plug into 2 to the 5th over 10 minus 2 times 2 to the 4th. That'd be 2 to the 5th again over 4 plus 2 times 2 to the 3rd plus 2 to the 4th over 3. Yeah, I mean, this is they're not gonna mark you down for this. I don't like it when they have these types of problems because then the issue is that if you mess up on your algebra here and then you have that answer, like it's like whatever, let's just say it's 1,000 and it's wrong, then you're not gonna get the points, even though you did all the calculus part right. This is just the algebra part. So unless really unless you have a lot of extra time and just love taking risks, go for it. But or maybe you just know your powers off, like maybe you're some sort of genius. Anyways, the last part, right, but do not evaluate an integral expression that gives the volume of the solid generated when region S, as described in part B, is rotated about the horizontal line y equals 20. Okay, so flashing back. So we're going to rotate it about this line up here. Spin it around. This is the line y equals 20. So if you remember what we have here, we're rotating this part here. So then this is this up to this line here, the G, that'll be our small radius. We'll call that little r. And our big radius will be all the way to the outside there. That'll be big R. And if you remember what you should hopefully, it's just the volume for a cylinder. So the volume would be then pi times, or you can keep the pi on the inside, or the outside, pi times integral of the large radius, large R of x, squared minus small r of x squared. After you factored out the pi dx, from a to b. That's the basic formula. And then we just have to figure out what the large radius would be and what the small radius would be. The large radius is always 20 because you're always going to here. It's always going to be 20 around because if you remember when you have a cylinder, let me see if I can draw this. You're rotating something like that, but in this cylinder, you have the whole of the small radius. So the large R of x, where should I write this? Here's the paper. The volume will be integral from 2 to 5. $20 squared minus the small r of x will then be 20 this length minus this length here. So that'll be 20 minus g of x. And you could leave it as g of x. You don't have to actually write out the polynomial. And then this is what they're looking for. So large radius minus the small radius. Oh, if we don't forget the pi. Woo. Pi, man. They're tough on these tests too. They can probably mark off you get the whole thing wrong sometimes if you just, because maybe this part I can imagine that maybe this part's only worth 1 or 2 points. Because they're really interested. Like this, remember, they're 9 points each. And who knows what they make this. Maybe they'll make this a 5er and this is like a 2 and a 2 or 3, 3. Yeah, it's probably not gonna be 3, 3, 3. But just be careful. Yeah, there you go. That's your answer. So I believe in myself and I think I did all these right, but if you find a mistake I was confusing in something, just let me know, give me some feedback, leave me a comment or whatnot. And I'm always trying to improve. I'm not the best. I'm working on being the best, but I'm far from it. So any advice I would be grateful for. But if you are finding these, helpful, let me know that and let me know that too. And, give me a thumbs up or just give me, just let me, positive feedback is always helpful. Anyways, thanks again. And I'll see you guys next time in the next video.